Hey, what's up there? Yeah, I don't know when GMOs became a thing either, but what I'll try to do is explain to you the contrary argument as to why people don't think they're harmful as simple as possible, so anyone, even if they don't have a science background, should get a pretty good idea of why people don't believe that. So there are two main reasons. Number one, there's no evidence for it, which is self-explanatory, but it's really not the deal breaker. There are a lot of things that people use and that are basically true, even though we don't exactly know how they work. So if you think like gravity, take this book, I let go of it, it's going to drop. No one's really quite sure the exact mechanism of gravity, but we know the result. It's the same thing with plenty of medicines. There are a lot of medicines out there that we don't know the exact mechanism by which they work. The other day I did a video on Provigil and Nuvigil. No one's exactly sure how the mechanism works. There are a lot of theories, but they're not exactly sure how it works. But still, we can see the results, so therefore we're able to use it as a medicine. But the main reason is not that. It is because it's something similar, but it's that there's not really a way that, evidence aside, forget about evidence, just come up with a way by which a GMO could harm you, just any hypothetical mechanism. So if you're going to make a theory, then what you would expect is for someone to say, well, I don't have evidence that this is what's happening, but this is how it could work. So if you think of something like, back in the day, the geocentric theory of the solar system, the astronomical tools they had were not that great, so you couldn't really prove one way or another, or at least a lot of people didn't think they could. It doesn't matter anyways. The whole point is that they had a theory, didn't have direct evidence for it, but what they said was, well, here's the Earth in the center, and this is how it could work. And if you've ever seen those charts where the planets orbit in little squiggly circles like that, that is the theory of the geocentric solar system. But what they have there is a hypothetical mechanism. We don't know if it works like this, but it could work like this. But with GMOs being harmful, I've never really heard of even a hypothetical mechanism of how it could work. And when I think of myself of how could it possibly be harmful to me if I were to eat a genetically modified organism, I can't think of one. And let me explain to you why. So I'm just going to take it from the top. So we've got to think of what a genetically modified organism is. So you've got DNA. DNA is, I'll tell you what, I'm going to use this as an example, just to make it really, really clear in case you don't have much experience with this kind of stuff. So DNA is the building blocks of life. It is what is the instructions for your body to do certain things. So if you compare it to a book, DNA would be like a word. DNA codes for amino acids. Amino acids together build proteins, and proteins are the main components of cells that basically do all the work in your body. Proteins make up the cells, and then the cells make up the body. So if you want to compare it to a book, DNA is like a word. An amino acid is like a sentence. The sentences make up the paragraph. A paragraph would be like the proteins. So DNA makes amino acids make up proteins make up the cell makes up the organism. So if you think about it, DNA is the words, amino acids are the sentence, the paragraph would be like the proteins, and the chapter would be like a cell, and the whole book would be the organism. So think of it that way, okay? So that's what DNA is. And when you change something, well, let me say, so when you make a genetic modification, so if you think of the book, it has a certain set of instructions, right? It says do this, do that, do this, do that, do this, do that. When you make a genetic modification, you're altering some steps. So it's like if I cross this out. It's like if I changed a word in a paragraph. It could change the meaning depending on what kind of change you make. So that's what basic genetic modification is. If I change enough things, it might change the meaning of just the sentence, it might change the meaning of the whole paragraph, it might change the meaning of a chapter, it could change the whole meaning of the book. It just depends on what you do, right? So that's basically what genetic modification is, okay? And the argument that people make is, well, if you're modifying the genes, it could be harmful to organisms, because when you genetically modify organisms, it's harmful to the organism itself because you make one change. It's like if you make a change in just one paragraph here, and it makes it contradictory to the rest, it could be harmful to the book, to the story. So it's like if you think of like a story like Harry Potter, if you change just one incident and it keeps referring back to this incident that you changed, it messes up the story. So it's harmful to the organism So it would be harmful to the book that the change is in. But is it harmful to eat the book, in essence, is really the argument. But of course, here we're not eating books, we're eating meats and fruits and things like that. So the main argument here is that no, because when you eat something, it breaks it down into its component parts. So when you eat something, it breaks it down into the amino acids, sugars, fats, and other kinds of minerals and just basic parts. So if you think about it back to the example of a book, if you digest a book, let's say what you're doing is you're just breaking all of this stuff, all these words, down into their individual little components, their little words and stuff like that. So if I take all these words and I just break them apart and jumble them up in a bag, what are the instructions that are in there? It's totally meaningless, basically, right? So that's basically what happens when you digest something. So even though it might have some instructions in there, they're not going to have any meaning to you once you digest them, because it's just going to break them down into their component parts. And DNA is it's very vulnerable. So DNA is a double helix, right? It's got a strand going this way and a strand going this way, and they meet in the middle. If you increase the temperature by too much, what happens is the strand splits. When the strand splits, the information is useful. That's why people are very temperature sensitive. That's why your body has a constant temperature. And when you get sick, the body temperature goes up. That's why when you get like a cold in your throat, some DNA can only withstand a certain temperature. So your body increases the temperature to denature viruses that occur in your throat. And the reason they're in your throat is because it's cooler. It can't enter your body anymore because it's too hot for it, which is why the body increases its temperature. To denature it, now if the instructions are jumbled up like in this book, then guess what? It's useless. So it cannot cause harm. So if you eat something that's genetically modified, it doesn't matter what the genetic modification is. So think about this. If you were to kill a cancerous tumor, just chop it off, throw it in a refrigerator, leave it there for a couple weeks or a freezer, and then throw it on the grill, cook it up, and then eat it, what would happen to you? Would you get cancer? No. Because when you digest it, it's going to break it down into all of its little constituent parts. Not only that, but once you throw it on the skillet or the grill, it also goes through a different step where a whole bunch of different bonds take place. In the body, there are a whole bunch of very reactive groups. That's why when you cook something, it's going to undergo a process called glycation, where sugars are going to start bonding to each other. That's why when you cook turkey, it turns brown. It's sugars bonding to each other. And the DNA, of course, it's going to get destroyed. It's going to be jumbled up, bonded to a whole bunch of other stuff. It's going to be totally illegible. It's like when you cook a book, where it's just, you take the book and then you just scramble up words. It's meaningless. It doesn't matter what's written. It doesn't matter if it was a tumor, which is a tumor is a genetically modified organism. It's probably the most harmful genetically modified thing you could eat. But yet when you eat it and it breaks down to its parts, the instructions are lost. When you cook it, the instructions are lost. When it gives off that steam, that's water being released from different bonds taking place. Just random bonds. So if you just mix up these words randomly, there is no more instruction. So there is no instruction. So that's why when people think of eating genetically modified organisms, it doesn't really make sense that they can be harmful to you. And if you think about it in that context, and where the instructions are lost when you cook it and when you digest it, how can it possibly harm you? And it really doesn't matter that it's genetically modified. People are undergoing genetic modifications all the time. Right now, during this talk, there have been mutations, and my genes have changed. So to talk about it like it's unnatural, it's really ridiculous. There's nothing more natural than genetic modification. It's the whole point of nature. It's the whole point of evolution, for genetic change. It just happens they're steering this genetic change in a particular direction. But otherwise, if you think about it, just because something is genetically different doesn't mean it's bad for you. If you were to eat a lion or a tiger or a giraffe, would it be bad for you? The genes are much different than yours. No, you would just eat it like any other animal, because you're just going to break it down into its constituent parts. Otherwise, if you think, otherwise eating fish or something like that would be really bad for you. Because if you think about it, for the longest time, people weren't able to access things like tuna. The only kind of fish you're able to get are the ones that came really close to shore. What about all those deep sea fish? I mean, those may as well be super genetically modified, because you would have never come into contact with something like that. Or like a lobster. People eat lobsters. Does anything bad happen to them? No. But if you think about it, your body was not evolved. You didn't evolve with lobsters. It must have been really damn hard to get a lobster back in the day, because they lived deep in the water. You couldn't go underwater. So that's why this kind of argumentation it really doesn't make any sense. The instructions are lost, and just the argument of it just being natural, it is natural for genetic modification to take place. If it's made of proteins, fats, and sugars, it's going to be broken down. So unless there's some other mechanism that someone can come up with, that's why it's hard for people to believe that and to be at any way at all concerned. So I hope you found this explanation helpful. If you still have another question about it, maybe I could make it more concise or go into another detail a little bit more. As far as I know, I'm not an expert on it, but that's all I know just from basic biochemistry and just stuff like that. So hope you found it helpful, and I'll see you next time.